By Newton-Raphson method, find approximate root of x cube minus x minus 1 is equal to 0 up to 2 approximation taking initial root 1. In this example, as we have given algebraic equation x cube minus x minus 1 is equal to 0, as right hand side is 0. So we have given f of x, that is function of x, as a x cube minus x minus 1. Put it as number 1. As we are going to here use Newton-Raphson method, so we have to take derivative of this function of x. So we differentiate this with respect to x, as derivative of f of x is always f dash x. As on right hand side there is a subtraction of terms, so we take derivative of each term separately. As derivative of x cube is a 3x square minus derivative of x is always 1, and derivative of 1 as a constant is a 0. So f dash x we get 3x square minus 1. So we put it as the number 2. Now taking here, as we are provided initial root take as a 1, so we need not define first here interval in which root lie, and out of one endpoint we take as the initial root. Instead of that, we take here as initial root x naught as given value 1. So to find x1 we need x naught, f of x naught. For that we take x as 1 in equation 1. On right hand side we get 1 cube minus 1 as 1 cube is a 1 minus 1 0. So we get f of x1 as a minus 1, and f dash x naught also. So for that, take x as a 1 in right hand side of equation 2, that is 3 into 1 square minus 1, actually 3, 1 square 1 3 minus 1 is a 2. So we evaluate here x naught and f of x naught. So using this value of x naught, f of x naught, f dash x naught, we evaluate first approximate root, as we have a formula x1 is equal to x naught minus f of x naught divided by f dash x naught. By putting the values, as we evaluate each term term on right hand side, as x naught 1 minus f of x naught is a minus 1 divided by f dash x naught as a 2, it will be 1.5. So first approximate root will be 1.5. Now we check whether it is an actual root or not. For that we take x as 1.5 in the equation number 1. On left hand side we get f of 1.5, on right hand side we get 1.5 bracket cube minus 1.5 minus 1. Using calculator we can evaluate f of 1.5 as a 0.875, as this is a positive value. So 1.5 is not a root of this algebraic equation. So we have to need find second approximate root. For that we x2, for that we need x1 as a 1.5, f of x1, that is f of 1.5, and f dash 1.5. For that we take x as a 1.5 in a right hand side of equation number 2. So it becomes 3 into 1.5 bracket square minus 1. Again using calculator we can evaluate f dash 1.5 as a 5.75. Now using this x1, f of x1 and f dash x1, we calculate second approximate root x2, as x2 has a formula x1 minus f of x1 divided by f dash x1. As we calculate all terms on right hand side, now put them as x1 1.5 minus f of x1 as a 0.875 and f dash x1 as a 5.75. Using calculator again we can evaluate x2 as a 1.347, and this is our answer, as we have asked here to take only two approximation. So first approximation have a root 1.5 and second root has approximation has a root 1.347. Using Newton-Raphson method, evaluate cube root of 100. As in this example we have to find cube root of 100, as we don't know value of cube root of 100, so we put it as a x, as x is here unknown. So this is the equation consisting unknown, which is this is equation, it's called algebraic equation. Though this is an algebraic equation, but it contains a radical sign. As we know, cube root of 100 means 100 raised to 1 by 3. So we simplify the index by taking cube on both sides, so that the cube root get cancelled with cube and we get left hand side as 100, and on right hand side we get cube of x cube. Now this equation can be simplified into standard form of algebraic equation by taking 100 on right hand side, so we get right hand side x cube minus 100 transfer it on left hand side, so we get the equation x cube minus 100 is equal 0. As 0 is on right hand side, we have here given f of x is equal to x cube minus 100. Now the solution of this algebraic equation is x, which is the value of here cube root of 100. So finding cube root of 100 means we have to find the solution of this algebraic equation, in which f of x is a x cube minus 100. We put it as a number 1. Now we have to use here Newton-Raphson method. As we know, in Newton-Raphson method we need derivative of function of x, so we differentiate this f of x with respect to x. As f of x has a derivative f dash x, on left hand right hand side there is a subtraction of two terms, so we take separate derivative. As derivative of x cube is a 3x square and 100 is a constant, so its derivative is 0, so we get f dash x, put it as a number 2. Now in Newton-Raphson method we need initial root, not an interval in which root lie. As we know, 100 is a number which here we have to find its cube root. As we know, 81 is a number whose cube root is a 3. Sorry, 81, not 81. 81's cube root is not 3. As 64 is a number whose cube root is a 4. As 125 is a number whose cube root is a 5. That means 100 is a between 64 and 125. That means the cube root of 100 lies between 4 and 5. So we can take initial root as a 4 or initial root as a 5. So in this case we take initial root x0 as a 4. To find x1, that is first approximate root, we need f of x0, that is we take x as a 4 in equation number 1 on right hand side, so we get 4 cube minus 100. As we know, 4 cube is 64 minus 100 is equal to minus 36, and f dash x0, that means the derivative of first order derivative of function for x is equal to 4. Put x is equal to 4 in equation right hand side of equation number 2, so we get 3 into 4 square. As 4 square is equal 16 into 3 is equal to 4 square say 48. Now we can evaluate first approximate root by Newton-Raphson method. The first approximate root x1 is equal to in term of x0 minus f of x0 divided by f dash. As the right hand side, all the terms on right hand side we calculated by putting them, as x0 is equal to 4 minus f of x0 is equal to minus 36. I put it in bracket, and f dash x0 as a 48. By using calculator we can evaluate x1 as 4.75. So first approximate root is a 4.75. We check it is a actual root or not. So for that we take this value of for x as a 4.75 in equation number 1. On left hand side we get f of 4.75. On right hand side we get 4.75 bracket cube minus 100. By using calculator we can evaluate here f of 4.75 as 7.171. Now the f of 4.75 is a positive value, not equal to 0. So 4.75 is not a root. So we have to need to calculate next approximate root for x2. For that we need x1, as we calculated here f of x1, as x1 is a 4.75, we calculate 4.75, and f dash x1, that is f dash 4.75. For that we put x as a 4.75 in right hand side of equation number 2, so we get right hand side 3 into 4.75 bracket square. Again by using calculator we evaluate f dash 4.75 as a 67.68. Now using x1, f of x1 and f dash x1, we calculate second approximate root x2. The formula of x2 will be x1 minus f of x1 divided by f dash x1. Put the value as x1 is equal to 4.75 minus f of x1 is a 7.171 and f dash x1 is a 67.68. By using calculator we evaluate here x2 as a 4.64. So we get x2. Now check whether x2 is a actual root of the given algebraic equation. By putting x as a 4.64 in equation number 2, we get f of 4.64 on left hand side, on right hand side 4.64 bracket cube minus 100. As using calculator we get f of 4.64 equal to minus 0.1026. As this is a negative value, so 4.64 is not a root of a given algebraic equation. So we have to find next approximate root. For that next approximate x3, for that we need x2, which is 4.64. f of x2, that is f of 4.64, we have calculated, and f dash x2, that is f dash 4.64. by putting x as a 4.64 in equation right hand side of equation number 2, we get 3 into 4.64 bracket square. By calculating this using calculator, we get 64.58. by using value of x2, f of x2, f dash x2, we evaluate the third approximate root x3. The formula of x3 will be x2 minus f of x2 divided by f dash x2. By putting value of x2 as a 4.64 minus f of x2 as a minus 0.1026 and f dash x2 as a 64.58, we get x3. Now here x3 is again 4.64. As you can observe here, the successive iteration has same result, that is x2 is a 4.64 and x3 is a 4.64. In such a case we stop the process, as we cannot further improve the result. That means the root of this algebraic equation is a 4.64, which is a value of cube root of 100. So we get finally cube root of 100 is equal to 4.64.